Okay, so today will be the introduction to our beginning of studying circles, and we'll kind of start it off transitioning from what we've done in our last unit. So looking at this picture here, we have what we studied the last 2 units, a triangle, and what we're going to be studying the next 2 units, a circle. And some of this will be a review. The definition of a circle is the set of all points in a plane that are equidistant from the same point, which is a given point called the center. And this distance is the radius. And we name the circle by giving the point that's the center a letter, and then that's the name of the circle. So if we look at the circle we have here, our name of our circle is circle O. That's the label on our center point. And we're going to use a straight edge to do each one of these tasks here. We're going to draw segment OB. That is a radius. The end points of OB are O and B. O is the center and B is on the circle. A circle has an infinite number of radii. So that's what we just drew in a radius. Now if we draw in using a straight edge in the segment A to C, and also B to D, we notice that AC goes through the center of the circle, but BD does not. However, both AC and BD have their endpoints on the circle. So one has got a little bit more special property than the other. BD is not a diameter of the circle because it does not go through the center. O. The length of a diameter of a circle is always twice the length of a radius. We've seen it written as D equals 2R. And the radii of the same circle or of congruent circles are always congruent. Okay, now that's probably all review. We're going to do some 2 new vocabulary words. One is called a secant. A secant of a circle is a line that intersects a circle at exactly 2 points. So we're going to use a straight edge and draw a line that intersects our circle Z in exactly 2 points, which we will label A and B. And then we have someone looking at our problem here and says, Mariella says that the chord of a circle is part of a secant. Chris says that a chord is different from a secant, explained by they're both correct. Well, I would say Mariella is correct in that segment AB, which is a chord of our circle, is part of the line AB. Chris is also correct because a secant is a line while a chord is only a portion of a line or a line segment. And it asks us which type of chord will always be the longest chord of a circle. It's going to have to be a diameter. Now we're going to look at a tangent to a circle. And a tangent is a line, again, that intersects the circle, this time at exactly one point. So we would use our straight edge to create a tangent line that intersects circle Z at one point. And then if we pick another point on the circle, point B, how many tangent lines could we draw through point B? And using our straight edge, we would discover that the answer is exactly 1. And the difference between a secant and a tangent line, a secant line intersects a circle in 2 points, while a tangent intersects in exactly 1 point. All right, so now we want to fill in our little chart here and check off the characteristics that correspond to each of our parts of a circle. So we have, is a chord a line? It is not. It is a line segment. Is the secant line a line? Yes, it is. Is a diameter a line? Nope, it is a line segment. It's a portion of a line. Is the radius a line? No, it's a segment. Is a tangent line a line? Yes, it is a line. So then let's kind of look at a line segment. So of course, since I'm talking about a segment, I can only look at those things that I checked off as being segments, as possibilities. The ones that say a line, well then I only can entertain the selections that I've checked as a line as possible answers. So if I go back to a line segment with both endpoints on a circle, that is the definition of the chord. And a diameter is just a special type of chord. Okay, a line segment with one endpoint on the circle, well, that would be a radius, because we have one on the center and one on the circle. And we have a line segment passing through the center of the circle, and that would be our diameter. Now we're looking at picking between secant and tangent. A line that intersects the circle at exactly 2 points is the secant, and exactly intersecting in 1 point is the tangent. And now when we put these segments of a circle together, we can create different angles. And the first type of angle we're going to talk about is a central angle. A central angle is an angle whose vertex is the center of the circle, and the sides, or what creates the angle, are radii. Now there's another type of angle that's called an inscribed angle. And if you notice, an inscribed angle looks different than a central angle, and that's because it's created differently. Here the vertex is on the circle, not inside, specifically in the center, but it is a point on the circle. And this time, what's creating the angle is not radii, but chords. So now what we want to do is just determine what type of angle we have and kind of justify why we said what we did. So here in this picture, we know we've got a central angle because the center is the vertex and the sides are radii. This angle here would be an inscribed angle because the vertex is on the circle and the sides are chords. Okay, there's a couple of problems for you to try here based on the definitions that we just went through. So maybe pause the video and take a few minutes to do that. And just a couple more things we want to talk about definition-wise. Now that we've created the two different types of angles, either using the center and two radii, or a point on the circle and two chords, we want to consider the portion of the circle that is captured by those angles. And we are called, the portion of the circle is an arc. And it's the portion that we're interested in that's intercepted or captured by our two different types of angles. And how we would talk about, if this was A and this was B, we would denote arc AB as letters AB. This would be segment AB, a straight piece, versus arc AB, which is a curved piece. And then depending on the size of the arc, we're going to go ahead and classify those. So if we kind of think back to our triangle unit, we talked about the three types of triangles, acute, right, and obtuse. We can talk about different types of arcs. We have a minor arc, which could be thought of like as an acute angle. It's something that is less than 180 but greater than 0. And then we have a major arc, which would be anything that was greater than 180. But of course, less than or equal to 360, which would be the whole circle. And then a semicircle is exactly 1/2 of the circle. So the measure of a semicircle in degrees is always exactly 180 degrees. And if you'll notice, the semicircle is always going to be created by a diameter. So that diameter is what's going to be intercepting the arc, the special arc that we're calling a semicircle. All right, so if we look at each type of these arcs here, we're going to name this first arc. This is arc AB, and this is a minor arc. That's less than 180. And then we do the other arc here. We have to make sure that we use 3 points for a major arc, and it's got to be in the correct direction. So I have to start at B, go through C, and end up at A to capture that portion of the circle. If we look at this one here, again, we have arc AB, and this is a minor arc, less than 180. And then we have arc ADB, or we could name it BDA. That's the same arc. And that would be a major arc. Okay, there's a couple of problems for you to try. And then once you tackle those, you can go ahead and work on the practice problems for this introductory lesson to our circles.